All right, continuing with 5.3, excuse me. Let's go ahead and go to example number 5. We have to solve this trig function, but we first need to get it into the same trig function. It's easier to conform or transform sine squared into cosine rather than cosine into sine by itself, because there is an identity that relates sine squared and cosine squared. In fact, it's 1 minus cosine squared. That is equal to sine squared using the identity. All right, and then it just comes down to simplifying, grouping, and then factoring. So we're going to take this 2 on the outside and do declaw. All right, and then you get that. Sorry, I paused the video. Oh well. You get that. 2 plus the negative 3 is negative 1, and you still have negative 2 cosine squared x and 3 cosine x. Take the negative 2 and the negative 1, multiply them. Take the 3 and put that on bottom, and you're asking what two numbers multiply to get a positive 2 and add to get a positive 3. Well, that's 2 and 1. All right, then factor by grouping. Notice this cosine x minus 1 only has a 1. But this first 2 has a negative 2 cosine x, and we're still left with a cosine x minus 1. Noticing that this is the same as this, so we can factor that out. Whoops. And once we get factors, then we can set each of the factors equal to 0 and solve each one. So cosine x minus 1. In fact, I'll go ahead and solve this one. Cosine x equals 1. You're looking on the unit circle where cosine is equal to 1. Well, it is here and nowhere else, because cosine is the x value on the unit circle. So this is just 0 or 2n pi for general solutions. But let's check to make sure this isn't between 0 and 2 pi, and it's not. So this is 2n pi, which means every integer value of a circle. Let's take the other one and solve for cosine x by subtracting 1 dividing by negative 2. We're looking on the unit circle for where cosine is 1/2. Cosine is the x value. Cosine is 1/2 here and here. There is no pattern to get quickly between those two values, so this angle is pi over 3, and this angle is 5 pi over 3, so we have x equal to pi over 3 and x equal to 5 pi over 3. Once again, there is no shortcut to get between the two of them, so we have to say 2n pi. Next example, squaring and converting to the quadratic type, keeping in mind that there might be some extraneous solutions. When you have some like this, you got cosine and sine, and there's no way to go directly between the two of these values, at least quickly. So sometimes it's helpful to just go ahead and square it, and then keep in mind that some of your answers might be extraneous. So what I'm going to do is I'm going to take the cosine x plus 1, and I'm going to square this side, and then I'm also going to square the sine and move from there. So I'm going to FOIL the left side. And then I'm going to convert the sine squared into cosine squared using the identity, which is 1 minus cosine squared. Then I'm going to move all of the cosines to one side and factor. And that is cosine squared plus cosine squared is 2 cosine squared. But then I still have the 2 cosine x, and then 1 minus 1 is 0. So that equals 0. Notice we have a square in a singular with no constant, which means factoring is a lot simpler. In fact, both of these just have a 2 cosine x. And I'm left with cosine x and a 1. All right, now that we've got it down into factored form, we can separate these factors and set them equal to 0. Noticing that cosine x is equal to 0. On the unit circle, cosine is the x value, so we're looking at pi over 2 and negative pi over 2. So let's just write the first, actually I'm going to write this as 3 pi over 2 between within the first circle. Let's not worry about the other solutions just yet. Actually, it says 0 to 2 pi, so it doesn't matter. Keeping in mind that some of these might be extraneous. So let's go ahead and take the other cosine x plus 1 and set it equal to 0. That means that cosine x is equal to -1. And on the unit circle, cosine x is -1 at pi. So x is equal to pi. Take these three solutions, remembering that we squared this, and when we square it, we possibly create an extraneous solution. Check out those solutions. I have this from the book. I just pulled it up to show you what they did. This checks to be true. This does not check to be true, but this one checks. Therefore, obviously, the one that does not check does not actually work out. All right, that's actually it for this video. I'm going to talk about this example in class.